Okay, now question 1 from this paper. This is paper 5, Planning, Analysis and Evaluation, February, March 2021, and the variant is 5.2. So the question number 1 is, a student investigate the vertical oscillations of the solid cylinder which floats in cooking oil. Figure shows the cylinder of the radius r. The student places the cylinder of the mass m in the oil. The cylinder is displaced vertically from its equilibrium position and released so that it oscillates. Period t of the oscillation is determined. The number of the cylinders of the different masses are available. It is suggested that the relationship between t and m is t is equal to 2 pi under root pi m over rho sigma k r square, where sigma is the density of the oil and k is the constant. Design a lab experiment to test the relationship between t and m. Explain how the result could be used to determine the value of the k. You should draw a diagram showing the arrangement of the equipment and then procedure, measurement, control variable, analysis, safety precaution. Okay. In this question, first of all, we will start with the definition of the problem. So first heading will be definition of the problem in this question. So under this heading, we have to write independent variable, mean which we have to change, the quantity which we have to change, and that is the mass of the cylinder. Mean the m. And the dependent variable is the depending quantity and the mass is the period. So the time period or the period t is dependent variable. So this is dependent variable and this is independent variable. So first of all, we have to mention these two. And then we have to write the constant. Yes, we have to keep the radius constant and we have to keep this density constant. So there are two constants. One is the radius r of the cylinder and second, the density of oil. We have to keep constant. So these are the two constants. So this is the first part, definition of the problem, independent variable, dependent variable, and then the constant. Now, next part of the question is the diagram. So first we have to show oil, some quantity of the oil in any container, large container, suppose this is the oil and this is the container. We have to label each and everything. So this is the container. This is the oil. And then we have to show different masses cylinder, but the radius must be same. Suppose the first one is this. And the second is this, keeping the radius constant and the mass different. At least we will show 3 cylinders of different masses. So this is M1, this is M2, this is M3. So these are the cylinders we have to label. And to measure the mass, we have to draw here a balance. Suppose this is a top band balance. So this is the scale in kg or in the gram, and this is the position of the cylinder to measure the mass. So we have to label it. This is top band balance or just right balance. Next, we have to record that period. For the time period, we will count the number of the oscillation, we will determine the time for the number of oscillations. Suppose this is the position of one of the selected cylinder of mass m, and this is in the equilibrium position. When it is displaced, it oscillates up and down. To measure the time period, we have to record the time for the several oscillations vertical. So suppose this is the stopwatch, and we will label it stopwatch. Next, we have to keep the radius constant. So definitely to measure the radius, an instrument is required, which is the vernier caliper. So this is the vernier caliper. So the drawing of each and everything must be labeled. So this is vernier caliper and the drawing with a pencil. So next, we have to keep the density constant. So for the density, we have to monitor the temperature of the oil. So here must be a temperature gauge, mean the thermometer. Suppose this is the thermometer. This is the bulb of the thermometer, and this is the bore inside capillary tube. We can hang it with the stand. So the label 8, this is thermometer. Okay, so this is the diagram. So the first heading is the definition of the problem. Second heading is the diagram. Now the third will be the procedure. Third heading, procedure. So first of all, we will write the operators is assembled or arranged as shown in the above diagram. And the next line will be mass of one of the cylinder is measured by using balance or top pan balance. Then the next is cylinder is placed at the surface of oil. Definitely it will sink partially. It will sink. Wait for the equilibrium position. So after the equilibrium, we have to displace the cylinder vertically down and release. It will oscillate. Record the time small t for number of vertical oscillations. Repeat this for same number of oscillation. And calculate the average, mean T average. So the T average is calculated. Then for the time period, use the formula. Time period is equal to T average divided by number of the oscillation. So it is measured. Now, after this time period, we will repeat same above procedure with other cylinders, keeping the radius and density, radius of cylinder and density of oil constant. So the radius is kept constant by measure it with the vernier caliper, and the density can be monitored, can be kept constant by looking at the temperature, by keeping the temperature same. So this is the procedure. Now the next heading is the tabulation. Just heading, no columns, number of observations, no reading, just heading with unit. So first independent variable, which is the mass in gram or in the kg, then the calculation of the dependent variable. So first we will measure time in second, first time in second. Second time, you can mention the number of oscillation, then the time average in second, and then time period in second, and last two column empty for further physical quantity. So mass in gram, time 1, time 2, number of oscillation, time average, and then the period. So the next heading is the data analysis. So in first step of this data analysis, we have to change the given equation into the linear form. So this is the given equation, either by taking square of the time period or by rearranging it, we can convert this into the linear form. For example, t square, taking square both sides, it becomes 4 pi m over sigma k r square and plus 0, because the straight line y is equal to mx plus c. So this is compared with mx plus c. So this m is independent, which will be plotted at the x-axis, t square at the y-axis. Then this will be the gradient and y-intercept will be 0. So sketch the graph. At the x-axis, we have to take mass in kilogram or gram. This is the origin, and then t square at the y-axis. So t square in second square. So y-intercept 0. So line will pass through the origin. The gradient is positive. So this is a straight line. And the gradient of this line is equal to 4 pi divided by sigma k r square. So we will write, if the graph is a straight line passing through the origin with gradient 4 pi divided by sigma k r square, where sigma is the density of the oil, r is the radius, then relation or given relation is tested, is justified. This is the first step of this. Now, Now this next step is we have to write the procedure here, the method, how to calculate this K. Look, from this equation, we can write K is equal to 4 pi divided by sigma r square times gradient. So we will write by using the equation, K is equal to 4 pi over sigma r square gradient, where r is the radius, which can be determined from the vernier caliper, and sigma is the density of the oil. So the density of the oil can be determined by mass of the oil divided by its volume. And the gradient is from the graph. So K can be determined. So this is the data analysis. Now, the next heading is safety precaution. So here we have to write one valid safety of the observer, mean the personal safety, not for the operators. So this is oil. Oil is flammable. So we will write, perform the experiment away from any fire source and avoid the spillage of oil. So this is just a safety because the oil near the fire source may catch fire. So this, which will be the dangerous. So this is the safety. And then last is either write good design feature, improvement, additional detail, it's up to you. Last heading is good designing features. Good design features are improvements. So we have to write at least 4. Number 1, look, this T is dependent on the mass to make this time period measurable. Keep this M large enough. So we can write the mass of the cylinder must be large enough, must be significant to get reasonable value for time of the oscillations. Then we will get the time period. And number 2, the radius of the cylinder cannot be kept constant by taking different cylinders. So for this, to keep R constant, take one long cylinder and then by cutting it from the top, mass can be changed. So this method will keep the radius constant. For example, this is the cylinder, radius is fixed. So first this height, then this one, then this one, this one. So in this way we can change the mass keeping the R constant. And the number 3, the oscillation of this cylinder must be in the vertical plane, not like this. It must be up and down straight. Otherwise, the result will not be accurate. So we have to oscillate it in the vertical plane up and down. Number 4, time must be recorded. Time T must be recorded for large number of oscillation to reduce human reaction error. And one additional suppose 5. Experiment must be performed in a closed, calm environment because oscillation may be affected by air thrust. So you can write any 4 because the 4 are required. So this is the question number 1.